Again, welcome to Python programming language. This is Introduction to Python Programming, lecture number 1. In this lectures, we're going to discuss about computer terminologies, the basic computer terminologies, also what is a hardware and software, how computers store data, and how a program works. Again, this is Python programming course, and this is our first lectures. So we start with computers. Here we say computers can be programmed, and they are designed to do any job that a program tells them to do. And that is our main objective in this course. In this course, we are going to use Python programming language to develop softwares that will instruct a computer to perform a specific task. So first we start with computers. What is a computer? A computer is any electronic device that can accept an input and be able to process the input and store the result. Also, it can be able to display the result. An input can be a data, different types of data, that a text, graphics, audio, and also be able to work with an electronic, in this case, a software application, and also a software system, which we shall come to that in a few minutes. So in general, a computer can be any electronic device that can accept an input, process the input, and be able to store the result, and also be able to display the result. We can also say that it should be able to communicate with other, again, devices. And so we should have a communication device. Now, computers can be programmed, as we said earlier, because it consists of two things, the computer hardware and the software. The hardware is the physical component, and the software is the program, the instructions to tell the computer to perform a task. So what is a program? Here we say it's a set of instructions that a computer follows to perform a task. Also, we refer a program as a software. The next terminology is what is a programmer. So a programmer will be a person who can design, create, and test a computer programs or a software, also known as software developer. Now, when we have a very large complex project, a software development project, we may also have a system analysis who are there to analyze the system, design the system. Then in this case, the programmer main goal is to implement or create the software based on the design given to him or her. So next we go to what is a hardware and a software. As we said, a computer system consists of a hardware and software. The two must work together. So the hardware will be the physical components such as a memory, the CPU, the monitors, etc. Then the software will be the instructions that we are going to store in the computer storage device, such as the hard drive, etc. So first we start with the hardware. The hardware, again, is a physical device that make up a computer. So a computer is a system composed of several components that all must work together. All the components must work together. So the typical major component of any computer system is the central processing unit. And we also call it the CPU or the processor. This is the brain of the computer. This is where the executions take place. The programs execute. We also need a memory. So this is the main memory component. This is where we store the data that we are working with, or the program that is being used is always stored in the memory. Then we also have the secondary storage devices. This is where we can store our data or the software, any information permanent. Then we need an input and also output device. Input device allow us to get an input into the computer system, such as the keyboard, an output device to be able to display results such as the monitor or the printer. So a computer system consists of a major, again, components. They are both hardware and software. And these are the major hardware components. So we start with the CPU. We say again, the CPU is part of the computer that actually runs the programs. execute the programs. So we can also say the CPU is the brain of the computer. It's the most important component of the computer. So without the CPU, we cannot run any software or a program. And also it used to be a very huge device, but due to microprocessor technology, CPU are very small now. So CPU is located in a very small chips. Also, the main memory is where the computer stores a program or a data while the program is running or the data is being used. So again, when we start our computer, we turn our power on. The first thing that happens is the booting process. This is where the operating system will be loaded into the main memory. The operating system is a special software that manages all the computer hardware components. So we do most of our work from the main memory. Also known as random access memory. We have two types of memory, the random access memory, which is called the RAM, and also the read-only memory, which is called the ROM. So the RAM is volatile. Volatile means when a computer goes off, all the data is gone. In terms of the ROM, the information is stored permanent and is used for specific purposes or perform a specific task. So that's why it's called read-only memory. We can't change the content. So CPU is able to quickly access data in RAM. Also, volatile memory used for temporary storage while the computer is running. The content are erased when the computer is off. The secondary storage device is where we can store data for permanent and long period of time. So programs normally store here, and also data are normally stored in a storage devices, secondary storage devices. So we have different types of secondary storage devices or secondary memory. And we have the disk drive. We have a solid state drive, flash memory, and also optical disk. Optical disk can be a common CD where we normally store music, information, etc. Input devices is any device that make it possible for us to input a data or an information, something to a computer. So a good example would be the keyboard or the mouse, touchscreen, scanner. We can scan a hard copy document and we can input that data or store it in our computer. An input to be the data that the computer collects from people and other devices. So these drives also can be considered input devices because they load programs into the main memory. Output device will be any device that make it possible to display the result from the computer, such as the monitor or the printer. So output will be the data produced by the computer or the result for other people or devices. And this output can be a text message, it can be an image, audio, or a bit stream. Output device, again, is any device that make it possible for us to, again, display the result or information from a computer. So a very good example of an output device can be a printer or video display, such as a monitor. A software, as we said, is a program. The software is a program, and the program is a set of instructions that tells the computer to perform a task. So here we say software is everything that the computer does is controlled by software because it's an instruction. Generally, we have two types of software. The application software, which is again perform a specific task, such as Microsoft Word document. We can create a Microsoft Word document such as a resume. I'll use the Microsoft Word program to create a resume. So Microsoft Word program, again, is application software, or a computer game for entertainment is an application software. Now, system software is any software that interacts with the computer hardware, manages the hardware and coordinates. So a good example would be an operating system. Operating system normally manage all the computer hardware resources. Another example can be antivirus or utility programs. An example of antivirus is a special software that make it possible to interact with the computer storage device, secondary storage device, such as hard drive, make sure there's no any viruses on it. So system software, as we said, program that controls and manage the basic operations of a computer. So operating system is a very good example. We also have the utility program, which perform a specific task to enhance the computer operation or safeguard data. So antivirus software will be a utility program. We also have the software development tools, and this is what we are going to use in Python programming language, such as a Spider or Anaconda or Jupyter. This is a software development tool. We write the source code and we run it, or we compile it and then we run it to develop the software. So a software development tool also is a system software. Again, we use it to create, modify, and test software programs. And we are going to use, again, Python or Spider for this course. Now, how computers store data. In computer system, the only language the computer understands is the binary numeric system, which we call the machine language, zeros and ones. So here we say all data in the computer is stored in sequence of zeros and ones. And every letter or symbol or unit is stored as a byte. So a byte is just enough memory to store a letter or a small number or a symbol. And then normally 8 bits makes 1 byte. A bit is a single unit of 0 or 1. And this can represent as on or off switch. On means 1, off means 0. Or positive means 1, negative means 0. Negative charge, positive charge. Now, storing numbers, as we said in a computer system, the machine language against 0 and 1. So all data store will be in numbers. So here we say bit represent 2 values, 0 and 1. Computers use the binary numeric system. And normally the byte size can limit from 0 to 255. So 0 means all bits off, 255 means all bits on, which means they are all 111. Now, storing characters, data store in computer must be stored as binary numbers, we said. So even if you are storing a character, there's a special program in the operating system that anytime we type a character, that program will convert that character, let's say A, into, again, a string of 0101, 8 bits. So here we say characters are always converted to numeric code, and the numeric code stored in memory. We have different standards of storing data or representing data in computer system. The most common one is the ASCII, which is up to 128 characters. But also we have the Unicode. Unicode coding scheme is very good because it's larger than ASCII. And also different languages such as Japanese or Chinese characters are also supported by it. So how a program works, we say normally a CPU designed to perform a simple operations on the pieces of a computer. And a CPU, a conventional computer, will do only 2 specific tasks. One is arithmetic operation, the other is a logical operation. So a CPU have a special component called the arithmetic logic unit. This is the main component of the CPU that does all the operations, can perform any arithmetic operations and then logical. Logical operation means a decision will be either yes or no, which we normally represent as true or false. So here we say understand instruction written in machine language and included in its instruction set. Every CPU must have its own instruction set. Again, each brand of CPU have its own instruction set. Now, to carry out a meaningful calculation, CPU must perform many operations. And this course, again, is a programming course, but normally in computer engineering, we have a computer architectural course where we go more detail about how we can develop or design and develop a CPU. So normally a CPU consists of logic gates, something we call logic gates. We have different types of logic gates, which will give us different types of output. Combining two or more logic gates together, we can perform different operations. So one CPU may even have billions of logic gates combined together, perform different operations. So here we say program must be copied from secondary memory to RAM. In the beginning, we said that the RAM, which is the random access memory, that's where a CPU can access a data or a program to do its execution. But at the same time, we also have a special type of memory called the register. Register is a special memory inside the CPU. So the data that is being executed, that very data will be on the register. So register memory is very small and it's very expensive. We also have a cache memory. A cache memory will be a memory between the RAM and the CPU. So this means CPU can access data very fast from a cache than from a main memory or RAM because of the distance. Also, CPU execution programs is in a three cycle: fetch, decode, and execute. So when we say fetch, first we read the next instructions from memory into CPU. Again, the CPU have a special component called a program counter. Always it points to the next instruction that need to be executed. So first we read the next instruction from main memory into CPU. Then we are going to decode it so that the CPU can be able to execute it, understand it, and execute it. So CPU decode fetch instructions to determine which operation to perform. Then it performed the operation in the execution phase. So again, CPU execute program in circles, fetch, get the instructions, decode it so that it understand it, then perform the operations on it. Now, from machine language to assembly language, the first programming language was normally written in machine language, because at that time we don't have any software development kit. We don't even have no operating system. So we have to write a program straight in machine language so that our program will directly can communicate with the hardware. There's no compiler or interpreter to doing it. So those days, again, writing a very small program may take a lot of time. But today, again, it's more easy. So first, we have assembly language, which normally use the short words. We call them mnemonics for instructions instead of binary numbers like 0, 1 writing. Now, this become more easier for programmers to work with. This is somewhere around the 1960s, late 60s, 70s. So the assembly language have a special component called the assembler. It's more or less like a software development kit called assembler. Assembler will translate the assembly language to machine language for execution by the CPU. Next, we move to the low-level language, which is close in nature to machine language. Now we have the high-level language, which allows simple creation of powerful and complex programs. Now there's no need to know how CPU works or even write a large number of instructions. It's more intuitive to understand. So example of a high-level language would be a Python. When we start our Python code, you will see that most of all the words are in English, a syntax. So we must have a special software that again will translate the Python language or most English language into machine language. Now also we should know what is a keyword. A keyword will be a predefined words used to write a program in a high-level language. So for example, in Python, we have a keyword print. Actually, print is a function or a method. And Python know what print means. to print something on our screen. This print must be lowercase, print lowercase. Now, if I use any uppercase letter, then it's different. So we call Python also as a case sensitive language. Print start with lowercase is different from print start with uppercase. So if I want to print something on my screen, I will write print all the characters in lowercase. We also have operators that perform different operations. We discussed about the common operations, which is the mathematical operations such as arithmetic, addition, subtraction, etc. Also, we should understand the term syntax. Syntax is a set of rules to be followed when writing a program. So syntax is the same as grammatical rules. So in English, when I write a sentences, I have to end it with a period. Same thing with Python. There are so many rules how we write our program. Also, a statement is more or less like a sentence. So individual instruction used in high-level language. I can write one statement to print my name on the screen. So that leads us to what is a compiler and also interpreter. So in high-level language, we need to translate the language into machine language. So programs written in high-level languages must be translated into machine language to be executed. So compiler normally will translate high-level language program into separate machine language program. So the whole concept is that a compiler normally will translate your code or the file one at a time, the whole file once. Now with interpreter, it will translate and execute instructions in high-level language program, and this is used by Python language. And it interprets one instruction at a time, so one line at a time. No separate machine language program. Source code is the statement that is written by the programmer. So a source code will be our Python language that we are going to write. A syntax error means there's a grammatical error in our Python source code. And normally the software development kit or the interpreter may identify it for us. So this is how it works. For example, here we have a Python code to print hello heading on our screen. So we write print, everything lowercase. We open a parenthesis. We start with a double quotation. We end with a double quotation, we close it. Now the open and close parenthesis is telling us a print is a function or a method. Then hello heading is in a double quotation, which means the data type is a string. And we will discuss about this when we start the Python programming code. So after we write the code finish, we are going to save it. Now you can save it with any name, but we have to end it with .py. Then that's the file extension for Python. Python file name .py. Then we use our interpreter to interpret it and it will convert it to machine language. This is what the CPU understands and it will execute it for us. In this case, it will print hello hidden in our screen, computer screen. Now using Python, first of all, we have to install Python. So if you go to python.org, you can download the Python, then from there we install it. So it's the same as, again, downloading any software, install it on your computer. You're going to follow the installation wizard instruction, very straightforward. So again, our first day of the class, this is what we're going to do. Go to python.org. We are going to download the Python idle, then we install it in our computer. But again, in class, we have computers already in the computer lab, and we're also going to use Python. At home, if you want to, you can again download Jupyter. If you already know any of the Python IDE, Jupyter or Spider, Anaconda account with Spider, etc. you can use. So this is the website for python.org. You can again download it. We have two sections. Part of it, we have the interactive mode, which works like a calculator. You enter your data, you press enter, you get your results. Then we have the script mode where we can write the code, we save the file, then we run it. And again, we're going to see an example. With the script mode, you create a file and you have to save the file. So it's written here, .py is the file extension for Python files. So again, we're going to do an example soon. And so that's the summary of this lectures. We cover, again, the basic terminology in computer system, what is a hardware, software, what is a computer, also how data is stored in the computer. We also discuss about the hardware components such as the CPU, memory, storage device, etc. Now, before we leave, I'm going to, again, in our computer, in the lab, we are using Python, but also you can use, it's up to you, you can use Anaconda or Spider. I have a Spider here, and we will do this in the class. And this is my Python. My Python here is a very old version, 3.4. I think right now we are somewhere around 3.10, 3.10.4. So if you go to the website, actually we can try that. But I think I'm 100% sure. I'm 100% sure the version is 3.10. And don't use the, don't use, it's supposed to be Python.org, not .com. So again, do not use Python 2. We are actually, if you go to python.org, the version is here, which will be Python 3. So you click on download, you see the Windows 3.10.4. Previously, we have Python 2 before Python 3 now, which is more updated. So when you go here, this website, you click download. Again, I don't want to do this because I have it already. So when you click on Python, again, it depends if you are using Windows. If not Windows, you see the options for 3 major operating systems we can use. One is the Windows. Also, we have the Mac, Apple, and also we have the Linux. So this is the interactive mode. When I click on Python 3.4, this is what now the interactive mode means. For example, I can use it as a calculator. 3 plus 9, when I press 5 plus 9, when I press enter, it will give me 14. Or I can create a variable. A variable is a memory location. I put 5 inside, create a second variable, let's name it E, and I put 10 inside. And this time I'm going to say T plus E, and that should give us 15. Again, we may discuss this later on. Now, if I want to print something on my screen, I start with the print. Let's say I want to print a string, and something is good, or let's say good. Now, here I have print good. So when I press enter, it will give me good. Now, so this is the interactive mode. Now you can go to the script mode by clicking on file. You have to create a new file. And here I'm going to write only one statement again, which is to print good. Now, when I finish, in this case, I can write more than one statement. The same thing with the interactive mode. And I'll click file, then I'll click save or save as, it's up to you. Then you give it any name. Here, I'm going to give it HHH. The only thing is .py. The extension is very important. So operating system know this is again a Python program. And I can see the name here, HHH.py. Now I can cross it as far as I know where I saved my file at. I can cross it and I can open it again. I save it in my desktop, cross it anytime I want to run it, I can run it. Now here I'm going to click on run. Then I'm going to click on Python shell or run module. I'll click run module. So you can see the result is good. Now let's make it a different character here, good John. And I updated it, so I'm going to save it and I'm going to run it again. And this time we will see good John. So those are the two options on the Python here. We can have the script mode. The good thing about the script mode is that this is saved, it's a file. I can go to my desktop and I'll see the file. I can open it and use it, but interactive mode works more or less like a calculator. So that will be the conclusion of our lectures for today. Again, this is our first lectures. We just went through some few terminologies, and hopefully in the next lectures, we will start with the Python code. Again, thank you.